Hi everyone! Over the next few videos, we're going to work on a program which interacts with the user using the command line. For example, the program will ask questions, then the user will type their answers, and finally the program will validate the inputs. This is a toy example, because in practice, we rarely read data from the console. However, this exercise is great for studying actions, because it presents most of the characteristics of a real-world application. 1. It interacts with an external system, the command line. 2. It is non-deterministic. We may get different results every time we run it. And 3. It can fail if the user enters invalid data. For example, if they enter a word when we expect a number. So in the first step, we'll implement this program imperatively. We'll try to make the code as readable and as testable as possible. Then in a second step, we'll develop a functional API to deal with actions. And we'll use this API to rewrite the console example. This way, we'll be able to compare an imperative and a functional approach to the same problem. Does that make sense? Okay, great. So now let's open the file user creation exercises in the package exercises.action.imperative. Be careful because there are other files with the same name in different packages. At the top of the file, you should see an app which executes the method readUser. Let's run it. So as you can see in IntelliJ, there is a green arrow next to the class name, next to the object name, so you can run it. If you don't use IntelliJ, you can also use this sbt command that I put here. You just put it in the sbt shell, and it will do exactly the same thing. Okay, so first we see a question, what's your name? So I can answer directly on the console. I can say Julian, followed by a question, what's your date of birth? Then there is a date format, 2 digits for the day, dash, 2 digits for the month, dash, and 4 digits for the years. So I can type my date of birth, 21st of July 1986, and I press enter. Finally, we can see a message, user is, followed by my name, my date of birth, and the timestamp at which the program was executed. As you can see, this program collects a few pieces of information, parses the data, and finally creates a user record. So the first exercise for today is to implement the function readSubscribe to mailing list. We can find it a few lines further down. So this method should ask a user if they want to subscribe to a mailing list. Then they will read the response from the console. Users can either answer with an uppercase Y for yes or an uppercase N for no. If they answer anything else, we should throw an exception. For example, an illegal argument exception. Note that to read a response from the command line, we can use the function stdin.readLine. You can find an example in the code above readUser, over there. So please pause the video and try to implement and test readSubscribe to mailing list. Okay, so let's try to implement it. First thing we're going to do is to print a message to the command line to print the question. So what do we need to ask? Would you like to subscribe to our mailing list, yes or no? Then we're going to read a message, read a line from the console. So we'll say val line equal stdin.readLine. And then we need to parse this line into a Boolean. So we can use, for example, a pattern match to do this. So we can say case, if it's an uppercase Y, then it's true. If it is an uppercase N, then it's false. And if it's anything else, we kind of want to throw an exception. So we can throw an illegal argument exception. We can say something like expected Y or N. Actually, you see that here it doesn't work because I use double quotes within a string. But you know, double quotes is the delimiter for strings, so I would actually need to escape it this way. But there is another way to do this in Scala. We can use triple quotes to create a string. When you use a triple quote, everything within the string is escaped, so we don't need to use backslash anymore. So here I can say expected Y or N, but received other. And so you see with this $other, I use the string interpolation we have seen before. And I need to, this is an exception, I need to throw it. Yep. Okay, so now how do we test this function? Well, we can't really test this, but we could potentially test this parsing logic. So let's try to maybe extract it. So I think there is a shortcut inside IntelliJ. Let me see if I can do it. Yes. Okay, so let's make it public and let's call it parse yes, no. So this is going to create a method down and refactor the code. So it's exactly the same, it's just extract the code into a method. And now we can write a test for this function. So in the file user creation exercises test, we can write a test for parse yes, no. So we could say parse yes, no, and write a couple of examples. So it's not going to be amazing, but you know, it's better than nothing, I guess. You can say if you call parse yes, no with a y, you expect it to be true. So we can say, you can assert it. Same for if you put an uppercase n, you expect it to be false. And then we could have a test for if you enter some rubbish. For example, if you say parse yes, no of, let's say, never, then in this case, it should throw an exception. So how do you check that it throws an exception? You can use try. So you remember try from the standard library. Everything that is within try will be a quote, and you know, if it throws an exception, we'll catch it and get a failure. Otherwise, we get a success. So, and then we can call a couple of methods on try. We can say is failure or is success. So for example, here we say we expect a failure. So this is one way to do this. Cool. So now let's go back to the exercises. So we can test the parsing logic, but we cannot test the interaction with the console, because our test cannot simulate a user entering data in the console. The only way to test this logic is to inject a console interface to the function. That will be the purpose of the second exercise. You will find a new version of read subscribe to mailing list a few lines below. This version takes a console argument, so let's open console. So console is a trait with two abstract methods, writeLine and readLine. Then in the companion object of console, here, you will see two implementations of console. The first one is called system. This is, if you want, the real implementation that prints and reads message from the command line. As you can see, writeLine delegates to println and readLine delegates to stdin.readLine. The second implementation is called mock, and as its name suggests, it simulates the interaction with the console using a pair of mutating lists. writeLine appends a message to the output list, while readLine consumes an element from the input list. So, in summary, we'll use system when we want to interact with real users, and mock in our test suite. So let's have a look at an example of one of the tests we could write using mock. So here we can see an example for read subscribe to mailing list. Here we want to simulate the user entering the capital letter N on the console. To do this, we create a mutating list with a single value, uppercase N. Then we create an empty mutating list to store the output of the program. Once we have these two lists, we create a mock instance of console and pass it to read subscribe to mailing list. The function returns a boolean, which we expect to be false, because we simulated the user entering the letter N for no. Now we can check what was printed on the console. For example, here we check that read subscribe to mailing list printed the question, would you like to subscribe to our mailing list, and nothing else. So let's enable the test. There are actually two tests for read subscribe to mailing list, and let's run them. So as you can see, there is one test that fails because the method is not implemented, and this one passes because we are checking a failure. So at the moment, the function failed because it's not implemented. So now it's your turn to implement read subscribe to mailing list using a console interface. So please pause the video and try to implement and test this method. Okay, so to implement this method, I suggest that we just copy-paste what we had before and replace the instances of println to console.writeLine. And instead of doing stdin.readLine, we do console.readLine. And hopefully this should be enough for the test to pass. Yes, they both pass. So as you can see, the advantage of injecting the console is that now we can test the interaction. Now let's see if we can improve the test. Now at the moment it's a bit annoying that it is an example, we just test one of the two values, we only test for n. It would be nice if we could use property-based testing to generalize a bit this test. So one way to generalize an example-based test into a property-based test is to take the input and to just randomize it. So for example here we could say, let's generate a random Boolean. So let's say this will be a yes, no, and this we know it's going to be a random Boolean. So the test framework will generate sometimes true, sometimes false. And then we can copy-paste the entire logic here. So the idea is that this yes, no, this Boolean is the one we expect at the end. So we always expect this yes, no. Now the question is, we need to somehow inject a string that will, we need to inject y when yes, no is true, and n when yes, no is false. So we could say, if yes, no is true, then we want y, otherwise we inject n, right? So let's run the test. Cool, nice. Now you can see it doesn't take, maybe it takes one more line of code, but at least here we test like the two possibilities. And if we had another test that would use like something like Boolean, there are only two possibilities, but if we had like a much bigger input type, at least the property-based testing will be able to generate all these variations, or at least a large number of variations. So I would say it's much better this way. Now, one quick thing that I would like to do is to extract these small methods into a function. So for example, I would go back to user creation exercises and write a function format yes, no. This way, so here we'll take a yes, no Boolean and return a string. And we just copy paste this. And inside of our test, now we can say format yes, no, yes, no. Okay, so we do the same. Potentially this format yes, no, we don't use it yet in our main code, but I find it nice to have both the formatter and the parser together because these two functions are really related to one another. So if they are really close to one another, there is more chances that if we change one, we'll modify the other one together. We could also write a property-based test that verify the round-trip property. If you generate a random Boolean, you format it and parse it, you should get back the same thing. I'll let you do that as an exercise. Okay, so next let's move on to read date of birth. So read date of birth is basically a method that's going to capture the interaction with the user for the date of birth question. So we'll ask, this function is supposed to print on the console the question, what's your date of birth, followed by the expected date format. Then we'll parse it inside of this date of birth, so we'll parse the user input and transform it into a local date, which may fail if the date format is not correct. Now one thing to keep in mind is that there is a method localDate.parse that allows us to parse a string into a local date. And I define a date of birth formatter, so this is a datetime formatter that describes this particular format that we expect. So 2 digits for the day, dash 2 digits for the month, dash 4 digits for the years. So you can use this formatter to parse the response. So please pause the video and try to implement read date of birth and test it using the console interface. So you should find already all the tests inside of user exercises test, but try maybe to generalize them using property-based testing. Okay, so let's first maybe enable the test for read date of birth. So I'll have this one and this one. And let's run the test. These two tests should fail now. Or at least one of them should fail. The one with success should fail. Cool. Okay, so what do we want to do? We first want to print a message to the console. So we'll say console write line, And which message do we want to print? What's your date of birth with the date format? Then we want to read a line, so we'll say console.readLine. And then we want to parse this line into a local date. So we'll do local date.parse. And what does it take? Okay, so first it takes the line, so the string. And then it takes the formatter, so the date of birth formatter. Let's run the test. All good, nice. Now, if we go back to the test, let's see if we could use the same strategy to generalize them. So what we want to do here is that, as you can see, this test at the moment, the success case, just check one particular input. So it just checked for 21st of July 1986. What would be nice is if we could generate a random date and then verify that, if we format this date appropriately and parse it back, we get back the same thing. So for example, we could say for all, let's call it date of birth. So we generate a random date of birth of type local date. And then what we want to do is that at the end of this test, we want to replace this hard-coded example by the one we generate. But in order to generate it correctly, we also need to change this to say date of birth formatter.format. So date of birth formatter, so format is a method that takes a date and format it as we expect. So let's run the test. So it doesn't work. Interesting. Yeah, actually, this is a bug that, this is actually a genuine bug that the property-based testing framework was able to find. So I'll let you investigate it on your own. So please run this test on your own machine and try to Google it, use Stack Overflow, ask your colleagues, any kind of techniques you will use normally, but try to investigate, the source of this bug on your own. So please pause the video and give it a try. Okay, so if you have a look at the error message that we get, so first let's try to explain it. This line explains what was the argument that was generated. So arg0 represents the first argument and the only arguments we have for our PBT. So here it says that it generated a date that is so this is 3rd of August for a year that is, far below year 0. And here, this is the error message that we get. So this is related to this assertion. It says that on the left-hand side, so the result of free date of birth, we got this date while we expected this date. So the second date is the one that was randomly generated. The first date is the date that we got from our method. So if you look carefully, you see that these two dates are the same, except that this one has a minus sign and this one a plus sign. So actually the problem we have is in our date of birth formatter. So here, if you look at this, I actually found this error in Stack Overflow while I was making this course, is that if you use the pattern Y, it actually doesn't handle negative years properly. If you want to handle negative years, you need to use the pattern U. So actually U is probably much better to use as a default. Now if we rerun the code with U, the test will pass. Now you might think that, okay, that's a cool anecdote, but in practice, my application never uses dates that far back. I don't deal with dates that are like 50 BC. So what we could do instead, so let's roll it back. Let's go back to YYY. And I also forgot to mention is that if you run this sort of test in your own code base, there is actually no default random generator for local date. Here it only works because I define this object date generator with a random generator for local date and a random generator for instant. So, so if you want to use local date or instant, random local date or random instant in your code base, you may have to copy paste this code. Now another way, I just would like to show you another way we could fix this test. So at the moment it will fail because I rolled it back to Y. Another way to fix this test is to say, okay, let's constrain the random generator to generate dates that kind of make sense. At the moment, we use localDate.min to say, okay, this is the earliest date in the past that the Java library supports. but it may not make sense. For us, we can say, okay, maybe our application only deal with date, for example, 1st of January 1950. And for example, now if we run the test will pass just because we constrain the random number generator. So generally, PBT are a great tool to find edge cases that we will never know on our own. And there are two ways to solve a problem. Maybe sometimes we have a proper solution like using this U in the pattern match. So I'll suggest to use it in this case. But otherwise, we can also constrain the random generator to generate values that make sense for our business. Okay, now last question for today. We're going to go back to user creation exercises, and we're going to implement a new version of read_user, but this time we wanted to make it testable because the previous version we had was hard-coded to println and stdin.readline. So if you want, we want a new version of read_user that uses the console interface. We want to make it testable. And it will ask 3 questions. What's your name? What's your date of birth? And would you like to subscribe to our mailing list? So we can reuse the method we did for the date of birth and the subscribe to mailing list question. And then at the end, we want to see this message printed on the console. So one thing to notice is that the current version of user doesn't have a Boolean flag for the subscription to mailing list. So I suggest that, how did I call it? I put it here in the comments. So add a Boolean flag to the user class. So you can say something like this. And let's remove this method because now anyway we're going to implement a new version of read_user that will be testable, and I will comment it for now. Okay? So now it's your turn. Please try to implement read_user so that it is now testable. Okay, so the first thing we want to do is to ask the question, what's your name, and then read a name from the command line. So what we could do actually is maybe to create a helper method like def read name that will take a console and return a string just to have the same patterns everywhere like this. And we'll say console.writeLine what's your name followed by console.readLine. I guess in a more realistic scenario, we'll probably apply some sort of validation rules to the name, maybe like check that it's not empty or something like this. But for now, we don't really care about this. So here within read_user, we are going to create a variable name that will say read name, and we delegate to console. Then we'll say the same with the date of birth. We'll say read date of birth. Same for subscribe. We'll say read, so was it read subscribe to mailing list, this one. So now this gives us access to the 3 fields. Now we need to create the user. So a user is a case class with 4 fields, the name, the date of birth, the date of birth, the subscribe flag. And then also we need to create a timestamp here. So to create a timestamp, what we can do is say now and use the method instant.now that will basically look at the time it is at the moment the method is executed. Okay? And also we need to print a message user is user something, so it's just like some kind of debug message. So we'll say user is and user. We'll use the string interpolator, and at the end we need to return it. Cool. Let's check if the test passed, so we can enable it. Oh, actually, here at the moment it would not compile because I need to uncomment this test. Okay, let's run it. No, it doesn't work. Let's have a look. So here we can see the diff. Basically, we got a user, but we didn't get exactly what we want. So we got the name right, we got the date of birth right, we got the subscribe flag right, but if you look at it, the timestamp is slightly different, which kind of makes sense because here within the test, we also use instant.now to read the time at the moment the test is executed. And here we use instance.now to look at the time the reducer is executed. But even though like these two methods are going to be called like just one after another, it's enough to get a different result. So really, if we want to make reducer testable, we also need to inject a clock, something that is able to simulate the time it is right now. So I created another trait that behave exactly like console. It has a method now with two implementations, system that do instance.now and constant that just return a constant. We could imagine more clever implementations that allows you to maybe either like it's a monotone, something like increment a counter every time it bumped by let's say 1 millisecond or something that allows you to set or move the time as you wish. But for now, we don't really need something more complex than that. So in our implementation, what we could do is instead of instance.now, we'll use clock.now, and we need to modify the test so that we need to generate a time. So we need to generate a timestamp. So we can say instant of, let's say, epoch seconds, and again, we can generate like a random number. It doesn't really matter. Then here we want to generate a clock, so we'll say clock.constant, and we'll pass this time that we just created. And then we'll pass clock to reducer. Okay, so once we have that, at the end, we expect to see this time inside of our user. So let's rerun the test. All good this time around. So in summary, we saw that actions are a bit painful to test. Not only we need to check the result of the function, but we also need to check the effects of the function on the external world. For example, reading or writing messages to the console or checking the current time. Today we saw that the most important point was to use dependency injection, meaning we had to encode all the dependencies with an interface and inject an instance of these interfaces to all the methods that we needed to test. This may be a toy example, but the same principle applies to production system that may depend on a database, a REST service, or an email client. So I suggest we take a break here, and the next video will be looking at adding error handling logic to this program. And if you want as a bonus exercise, I suggest that you go through this test suite and try to use a proper device testing everywhere. So for example here, we want to check that read date of birth fail because we injected an input in the wrong format. So below the video, I will add some instructions to help you define a custom generator for these sort of things. Okay, so have a great day everyone. See you soon.